Alright, this is Mr. Gillum, and today we're going to continue solving equations. And now we're going to actually throw in a little bit of distributive property in our equations. So it's going to be a little bit step of added difficulty to our two-step equations. We're going to add another step, the distributive property. Now I just want to remind everybody before we get started that last chapter we were doing expressions. There was never an equal sign. It was just an expression with terms. But now we have equal signs, and so now there's an end goal in mind. We have to get the variable isolated. We have to isolate the variable. We have to find what the variable could be to make the equation true. So we've been doing these extra steps that we didn't have to do with expressions, because now we have equations, and the equal sign is the fulcrum. So all the rules for the distributive property stay the same in an equation. However, after we get done distributing, we still need to isolate the variable. So in today's problems, what you're going to see is you're going to see some parentheses with a number in front. And since we've been learning about the distributive property, that's the first thing we're going to do is we're going to distribute. And then it's exactly like what we've been practicing. We're going to use inverse operations, but we're going to start with addition and subtraction, and then we're going to move to multiplication and division. And whatever inverse operation we use, we just need to make sure that it's something that's going to get us closer to solving for the variable or isolating the variable. So let's take a look at an example. And in this case, it says solve the equation. 2 times the parentheses x minus 6 equals 4. So if you remember, the distributive property says if you see parentheses in a problem, to get rid of them, you have to multiply whatever's in front of the parentheses times everything in the parentheses. Right? And so we talked about this a lot when we did expressions, and we spent a lot of time on this. But now we have an equal sign. Okay, so we have to actually get the variable by itself. Before we can do that, what we need to do is we need to distribute 2 times x and 2 times negative 6. Since we've done a lot of practice with the distributor, I know you're going to be good at this. 2x and then positive 2 times negative 6 is negative 12 equals 14. Nothing changes on the right hand side of the equal sign there because the 2 is only distributed to what is inside the parentheses. Since we've been practicing solving two-step equations now, you should know that, okay, the first thing I need to do is add or subtract to help me isolate the variable. In this case, I see this is a minus 12. I want it to be 0 because if I add 0 to 2x, it'll just be 2x. So in this case, if I add 12 to both sides of the equation, I know that negative 12 plus 12 is 0. And on the right-hand side, I know that 14 plus 12 is 26. See, now the strategy here is to isolate the variable. And I know that anything plus 0 stays the same. So I now have 2x. The inverse operation of multiplication is division. So now I will divide both sides by 2. I'm showing every little step on this first example. I know that 2 divided by 2 is 1. So now I have 1x. On the right-hand side, 26 divided by 2 is 13. I know 1 times x is still just x, so x must equal 13. Alright, so there's my solution. Now if I wanted to check to make sure that I had the right answer, because there's a lot of steps to these problems, I would just plug it in. 13 minus 6 is 7, and 2 times 7 equals 14, so I know I did it correctly. Okay, so you can do a quick mental math check when you're done. Alright, now I added a few extra steps in here, like the plus 0, just to show you what was happening, and the 1 times x. I know that you probably understand that already, so you don't need to have those steps in there, and I won't show those steps again. But I just want to make sure that everybody understands why we're adding 12 is to get this to cancel each other out, so we can get the x all by itself. Why we're dividing by 2 is to get these to cancel out, so we have x by itself. Alright, so there's a purpose between each step. I can always do add 5 to both sides, or add 10, or add 100 to both sides. I can do whatever I want in an equation because I know that the balance will stay equal as long as I add the same amount on both sides. But when I'm adding, I want to do something that's going to help me to isolate the variable. So if instead of adding 12 here, I would have added like 20, it wouldn't have gotten me any closer to solving for the variable x. So you want to be smart about which numbers you pick to add and subtract. You want them to be meaningful. Once again, today we're practicing equations with the distributive property. Before I can do anything, I would like you to distribute the negative 3 into the parentheses. Negative 3 times 2x is negative 6x. And this is the part I see a lot of mistakes on. Remember, this negative sticks with the 3, so we have negative 3 times positive 8, negative 24. And the 0 doesn't change again. Okay, so make sure here that you have a negative 24 on there. If I'm trying to isolate the variable, I want to see if there's anything I can add or subtract to help me get there first. And I know that since I have a minus 24, the inverse of minus 24 would be plus 24. And I know that's going to get me back up to 0. And if I don't have any constants left, then I'll just have negative 6x. So negative 24 plus 24 is 0. Once again, this is a step that I see people make mistakes on sometimes. It says negative 6 times x. Now I know it's very tempting to say, okay, well that says minus 6, so we need to add 6. That's not what's being held together with the variable, okay? It's held together with the variable by multiplication. So the inverse of multiplication is what we should be thinking. And in this case, it's division. We divide both sides by negative 6. I divide by the negative because I know a negative divided by negative will be a positive, and the 6's will cancel. Over here, I have a positive divided by a negative. When they're different signs, I know the outcome is negative. Okay, my quotient would be negative. So x equals negative 4. And once again, we could plug in to our equation to see if we got the correct answer here at the top and work it out to make sure that equals 0. But for the sake of time and what we want to practice today, I'll let you do that in your homework. Take a look at a couple more here. Negative 2 times x, negative 2x. Negative 2 times negative 9, positive 18. There's my balance point. Anything that happens on the left side of this line, this equal sign, has to happen on the other side. Looks like my first step, I want to get rid of this positive 18, and the inverse of plus is minus, so I'm going to subtract 18 from both sides of the equal sign. Negative 2x equals negative 7. Ooh, tricky one. Okay, now this is, some of you are going to think, oh, well, did I make a mistake? Because I can see right now that this isn't going to work out evenly. When I divide both sides by negative 2, because this is held together by multiplication, I do have x all by itself. All right. However, on the right hand side, negative 7 divided by negative 2, you begin to panic. But don't worry, you see this division sign that I put here? That's literally the fraction that you want for your answer. It just needs to be reduced. A negative and a negative makes a positive, so my answer is just 7/2. All right. Don't get flustered if you see that 7 divided by 2 doesn't work out evenly. Just use that fraction just the way you wrote it, 7/2. Okay, you don't need to change it to an improper or a mixed number. It's fine the way it is. Let's take a look at number 4 here. Negative 7 times negative 2x is 14x. Negative 7 times positive 1, negative 7 equals 5. So far, so good. Now I'm thinking, I'm going backwards from order of operation. So I see minus 7. I'm going to add 7 to both sides. Now, I don't want anyone to get confused about this. So what I'm going to do is I'm going to write it this way. 14x minus 7 plus 7 equals 5 plus 7. Sometimes when I write it right underneath, you think I'm just adding to this side of the addition sign. Okay, I'm not. I'm adding it just to both sides of the equation. So this is an expression over here. This is an expression over here, just like what we had done when we took our expressions test. So don't think that I'm adding the 7 to this part of the equation. I'm adding it to the whole side of the equation. But the only parts that can be combined together are the negative 7 and the positive 7. That makes the 0, so I just left with 14x. All right, I have a 12. Once again, sometimes I see students panic because they think, oh, well, 12 doesn't divide evenly by 14, so I must have made a mistake. But when you write your division sign like this, it's nice because that fraction is the actual fraction that you want to use. That's 12 divided by 14 is 12/14. All right? Just need to reduce it. So in this case, it'd be 6/7. There's my x value. Let's take a look at number 5. Once again, I'm going to start by distributing. Negative 4x. Please pay close attention to the negative and this negative. They multiply to make a positive, 16. And then I just need to continue on down the line here. Minus 16 from both sides. But this is the part I was talking about. I'm not subtracting 16 just from the side of the plus sign and the side of the equal sign. And I'm going to write it the long way again. What I'm doing is I'm just subtracting 16 from the whole side of the equation. So sometimes when I write it vertically, it's confusing on what I'm doing and where I'm doing it and why I'm doing it. It's always on both sides of the equal sign. But I'm just looking at this expression and this expression, and I'm simplifying them. I know x's can't go with numbers, and so the numbers themselves will just cancel out. Negative 4x equals 8. And I continue on with my division, because it has to be division because this is held together with multiplication. X equals negative 2. And there's my solution. All right. Do another one here. 2 times negative x, 2 times 6. Negative 2x plus 12 equals 4. Make sure that you're not distributing the 2 times the 4. They're on two separate sides of the equal sign. That would be inappropriate. Once again, negative 2x plus 12 minus 12 would equal 4 minus 12. See how I'm keeping the equation balanced here with the negative 12 on both sides? The reason I chose minus 12 is because I know that I'm trying to isolate this variable here. And if I choose negative 12, the positive 12 will be disappeared because they will cancel their inverses, additive inverses. Negative 2x equals negative 8. And once again, my division, x equals 4. All right. So there are two more problems for you to do on the back of your paper. I want you to do number 7 and number 8 on your own. They look like this. Okay. On number 7, the variable's on the right-hand side. Number 8, the variable's on the left-hand side. Be careful that when you distribute the negative, it goes to both parts. And over here, make sure that you understand that this negative 40, when you divide in the future, it might have to be negative. So I want you to solve those, and before I give you your homework on Monday, I want to see that you did them correctly. And if you didn't do them correctly, then I'm going to help you finish them, and then I'm going to give you your homework. All right, that's it for today.